So in this section, we're going to be taking a look at ellipses. Let's go ahead and jump right into ellipses. So our goal is going to be two things. One, we're going to want to write equations for ellipses in standard form. And when they're in standard form, there are going to be things that we can quickly identify, things like the center, and then other information that allows us to draw and graph out an ellipse. The second thing that we'll eventually get to is talking about the eccentricity of an ellipse. And eccentricity refers to basically how close the shape is to a circle. All right, so first we're going to be focusing on equations in standard form. So before we start taking a look at how to graph and even taking a look at the equation of an ellipse, I want to point out some parts of an ellipse that are important. So an ellipse basically is an oval. It's not a circle. It's more like a smushed circle, right? It's elongated, and it can be elongated horizontally or vertically. Now the one that we have here on the screen is elongated horizontally, meaning it's longer across the x-axis, which is the horizontal one. So a couple of things that we need to notice here. Of course, we're going to have a center, okay? So the center is the very middle of the ellipse. We also have the end points, which we call, well, each one is called a vertex, but if we talk about them together in plural form, they're called vertices. We also have these points that lie in between the center and each vertex, and individually, they're each called a focus. When we talk about them together, we call them the foci. All right, so we're going to talk about those a little bit later on, especially when we talk about eccentricities. But for right now, I just want you to know that ellipses do have these points called the foci, and they actually do have some pretty cool applications when you start exploring things like orbits of planets. Now, what's really important is to identify the major axis. So the major axis is always the longer axis. And in this case, because our ellipse is horizontal, the major axis is the horizontal axis. And what I want you to notice as well is that the major axis always goes through the center, the focus, and the vertex, or better said, the center, the foci, and the vertices. Now, the smaller axis is this one right here that is vertical, and we call that the minor axis, and I think that probably makes a lot of sense. It's the smaller one, so we call it the minor one. So notice that we only have the vertical axis, the minor axis, going through the center. The minor will never go through the vertices or the foci. If you're interested in writing down some of the notes for things that we just talked about in the previous slide, go ahead and pause the video and you can write down some of these definitions in your notes. There's an interesting purpose for the foci, and part of it allows us to help us draw out an ellipse without having an equation at all. So I'll put a link to this video so that you can see exactly how the foci help in creating the shape of an ellipse. Okay, now we're ready to dive into the equation of an ellipse. So what you see in front of you in yellow are two versions of equations that are for ellipses. Now, they look pretty similar, but there is one difference between them, and that difference happens in the denominator. Notice that when the major axis is horizontal, meaning my ellipse is long this way, we have A under the x parentheses. And the x tells us that we are on the horizontal axis. So the fact that there's a connection between the major axis being horizontal and x being above the a value is not a coincidence. So the a value is always going to be the larger of the two denominators. So b will always be the smaller one. Now this is very specific to the way that ellipses work. Once we get into hyperbolas, that's going to change. So it's important to keep track of the different meanings for these variables. So let's take a look at the other equation, and here they tell us that the major axis is vertical. So that means that our ellipse looks like this, and the major axis goes through it vertically, basically almost like a y-axis, which makes sense why a now would be underneath the y parentheses. So your bigger value is going to be your a value, and if a is under your parentheses with x, then you have a horizontal ellipse. If your a value is underneath the y parentheses, then your ellipse is longer vertically. So you can write this down in your notes if you'd like. What's most important here is really the equation. This is the equation for how to find the foci of an ellipse. So we have c squared equals a squared minus b squared. And we just saw that the a and b values come from the denominators of the equation for an ellipse when it's written in standard form. So this is not going to really affect too much of what we're going to be doing today, but later on when we talk about eccentricity, this will have, there will be more of a purpose for this specific equation. So for now, feel free to write it down in your notes, but we're not going to spend too much time on it today. So let's go ahead and jump into an example. So we're going to start off with a very basic example, and then we're going to try another one that's much more involved. So the instructions here tell us sketch the ellipse given by 4x squared plus y squared equals 36 and identify the center and the vertices. So let's just remind ourselves that the standard equation of an ellipse looks like this: x minus h squared over, and we know the denominator could be a squared or b squared. For now, I'm just going to make it a squared, and then y minus k squared over b squared equals 1. Okay, that 1 is really important. So the center, maybe you'll remember this from last year, but the center is hk. Okay, and what's unique about this is that the values for h and k are actually always the opposite of what you see in your parentheses. All right, so we'll get to that, but for right now, just keep that in mind. Okay, so let's go ahead and start working out this problem. So we have 4x squared plus y squared equals 36. Now what's interesting about this problem is that there's only one x value and one y value. Normally what we would see is actually two separate versions of each. We would have an x squared and then a regular x, and then a y squared and then a regular y. And that's not the case here, and I'm going to show you why. But what we want to do is, because we don't have this overly complicated equation to start with, really the only thing we need to do is make sure that this equation is equal to 1, because that's what standard form looks like. So I'm going to go ahead and divide everything by 36, because that's what's going to give me a 1 on the right side. So when I simplify all of that, right here, 4 over 36, that fraction reduces to a 1 over 9. So I'm going to write x squared, because I don't need to write 1 in front of it, over 9. And then I have y squared over 36, no fraction to reduce there. And then 36 divided by 36 is 1. Okay, now I'm going to go even one step further, and that is I'm going to rewrite my denominators in their squared form. So instead of writing 9, I'm going to write 3 squared. And instead of writing 36, I'm going to write 6 squared. Okay, so one thing to note here, we are now ready to graph, but the center would come from hk. And in this equation, we see that there are parentheses missing from the numerator. There's actually no value for h and no value for k. Well, in reality, those values do exist. They're zeros. And so we don't need to write them. We don't need to write x minus 0 squared and y minus 0 squared because we could simplify those, and that's what they give us. They give us the most simplified version. So because there's no x, or because it appears as if there's no h and k value, our center is actually 0, 0, the origin. So I'm going to go ahead and plot that point. That's my center. And then what I want to do is I want to start graphing this. Now, I need to understand, what the shape is going to look like. Now, a is always the greater value. So in this case, a is 6. I know a is 6 because it's literally just the bigger one. That's all there is to it. And a is below y. Okay, so I know that this ellipse is going to be long vertically. Okay, so here's the trick. Underneath x, we're going to move, or we see 3 units. So along the x direction, so the horizontal from the center, I'm going to move 3 units to the right and place a point, and 3 units to the left and place a point. And in my y direction, so up and down, from the center, I'm going to move 6 units up. So 1, 2, 3, 4, 5, 6, and 6 units down. And you can see that if you follow those instructions, you're going to end up with an ellipse that is just elongated vertically. So it makes sense when you just kind of follow the directions that they're giving you, right? In the x direction, so in the horizontal direction, move 3 units. In the vertical direction, which is y, move 6 units. And you end up getting the shape of the ellipse that you should. So as best you can, try to, with this nice smooth curve, try to close the shape. Please don't make it look like a diamond. No straight lines, all curves. And here we have the ellipse. Now we identified the center, but we also need to identify the vertices. Well, the vertices have to be the endpoints of the major axis. So which one's the major axis? Is it the x or the y? Well, because the ellipse is longest in the y direction, then this right here is considered the major axis. All right, so my vertices have to be these 2 points. So let's go ahead and write the coordinates for those 2 points. So we have, for the one that's above, we have 0, 6, and the one below, we have 0, -6. Okay, so here we have one that's more like what you'll be seeing on your homework. We have a problem here that has started out a bit more complex, actually a lot more complex, and so we're going to have to do a little bit more work before we can actually graph, which is what the instructions are asking us to do. So when we want to get something that is in this form that's given to us right now into standard form, we have to use the process of completing the square. So let's go ahead and do that. The first thing that we want to do is we want to group all of the x's and group all of the y's, and then we want to get our constants. So in this case, +9, we want to move all that over to the right side. So let's go ahead and start grouping. X squared plus 6x, and I'm going to leave a space because I know I'm going to have to put a number there, plus, and then I have my 4y squared minus 8y plus some number, so I'm going to leave a space, equals, and that +9, I'm going to move to the right side, but mathematically, so I have to do -9 on both sides, so I get a -9. Now, what we want to do is we want to complete the square. We want these trinomials, or technically right now you only see a binomial, but these parentheses will become trinomials. We want them to be perfect square trinomials. So we have to find that one number that when you multiply to that number and add to b, it's going to be the same exact number. So we have to remember the formula for completing the square, which is b divided by 2 squared. So let's go ahead and do that for the first parentheses, the x's. So here when I do b divided by 2, that's 6 divided by 2, which is 3. And 3 squared is 9. Now if I add 9 to the left side, remember you have to add 9 to the right side. All right, now let's do the next step. Now the next step is a little bit more work, so I'm just going to bring down my x's. But the next step is a little bit more work, or not more work, but there's one thing that we have to be careful with, and that is the fact that y squared has a coefficient. When you complete a square, you can never have a coefficient on your squared term. So I actually have to factor out that 4. So I'm going to do plus 4, and when I factor out that 4, I'm going to end up with y squared minus 2y plus something that I will be completing the square with. So now we are ready to complete the square. So let's go ahead and do b divided by 2. So that's a negative 2 divided by 2, which is a negative 1. And then a negative 1 squared is a positive 1. Now here's where we have to be careful, because on the left side, you physically see that I wrote in a 1. But do you remember that everything was actually multiplied by a factor of 4? I took a 4 out of everything. So this y isn't just y squared, it's actually a 4y squared. This middle term isn't just a negative 2y, it's actually a negative 8y. So this last term isn't actually a value of 1, it's 1 times a 4. So what I need to add on the left side is a value of 4, even though you see a 1 on the left. Okay, so again, if I were to distribute this, that would actually hold a value of 4. But for the purpose of completing the square, we factored out the 4, and so we only have a 1 in that spot. All right, so let's go ahead and continue. Now that we have our trinomials, we need to start factoring them. That's why we do this. So let's go ahead and factor this first trinomial. So two numbers that multiply to 9 but add to 6, that's going to be a 3 and a 3. So what I'm going to end up having is actually two parentheses that look the same. So I'm going to write that shorthand, and instead of having two binomials, I'm going to write that as x plus 3 and then squared, which represents two of the same parentheses. Now for the next one, we're going to do the same trick, and it's going to work because we completed the square. So two numbers that multiply to 1 but add to negative 2, well, that's got to be a negative 1 and a negative 1. Okay, so now on the right side, let's go ahead and simplify this. A negative 9 plus 9 is 0, and all we're left with is 4. So we are almost to standard form. What we need on the right side, remember, is a 1, and I have a 4. So I need to divide each of these terms by a 4. So I'm going to have x plus 3 squared over 4. If I simplify this fraction, they actually cancel out, and I'm just left with a 1. So I'm going to have y minus 1 squared technically over 1, and 4 divided by 4 is 1. Okay, so I'm going to fix this just in one small way, and that is I'm going to rewrite this 4 as a 2 squared. And 1 can be written as 1 squared. And that's going to help me graph. So first thing we need to do when we get ready to graph is we need to find our center, our h, k. So my h is always associated with my x. All right, so here is my h, but it has to be the opposite value. So that's going to be a negative 3. And here's my k. K is always associated with the y, but it's going to be the opposite, so that's a positive 1. So my center for this ellipse is negative 3, positive 1. So I'm going to go ahead and graph that point. Next, I need to find the 2 points horizontally and then vertically. So here in the x direction, so left and right, I'm going to move 2 units from the center. So 2 units to the left and 2 units to the right. And then in my y direction, I'm going to move 1 unit up and 1 unit down. And this one's a tiny ellipse. So there we go. That is the graph of our ellipse. It is elongated horizontally, which makes sense because A, the larger value, is this one, and that is underneath the x parentheses. So this ellipse is long along the x-axis or the horizontal axis technically.